This is the second set of notes for section 5.2 part 2, and we're going to continue talking about polynomial functions. Today we're actually going to be doing some operations with them, so we're going to start adding and subtracting them. I made these fairly short, so we might need to do some more examples together in class afterward, but I wanted to make sure you guys got everything without having this take forever. Alright, so first we're going to start with an example. So the first thing we're going to be doing is evaluating a polynomial. So I want you to write down, here's our polynomial. We're going to call it p of x, and it's going to be equal to negative x squared plus 4x minus 1. And our instructions are that we're going to find p of 5, and I'll do this one in blue, p of negative 5. So this is actually something we've pretty much already done. We're just plugging in a 5 and for the input, or the x in this equation, and then we're going to plug in a negative 5. So let's start with the 5. I'll do it over here in red. So we're going to plug in a 5 wherever we see an x in this equation. I think it's kind of nice to always put it in parentheses, just because it kind of helps you with any negative issues, like if the negative signs in your equations. So notice that I kept that negative that was in front of the x up here, I kept it on the outside of the parentheses when I plugged it in, because that negative was not in parentheses to begin with, so I don't want to keep it in there. I want to leave it on the outside. So let's go ahead and evaluate this. So we've got a negative times 5 squared. So this is a negative 25. The negative is not being squared. Plus 4 times 5, which is 20, minus 1. So negative 25 plus 20 is negative 5, minus 1 is negative 6. And that's it. We're just evaluating it. So let's go ahead and do, we're going to find p of negative 5 now. I'll do that over here in blue. So again, we're just going to plug it in using parentheses for now. So we've got negative, that's the negative sign out in front, and then we're plugging in negative 5 for x. So there's now two negative signs there. Plus 4 times negative 5 minus 1. So I just rewrote that equation up there exactly as I saw it, but I put negative 5 wherever I saw an x. I left everything else the same. So let's figure this out. We've got, let's talk about this part first. Negative 5 all being squared. Well, that's negative 5 times negative 5, which is positive 25. But we have that negative on the outside, so it's still going to be a negative 25 in the end. And then we've got plus 4 times negative 5. So that's plus negative 20. You could also just write minus 20 right there. That's usually what I do. And then minus 1 at the end. So negative 25 plus negative 20 is negative 45, minus 1 is negative 46. So what we're going to move on to next, and we'll do a few examples of this, is adding polynomials together. We've also pretty much done this before. So we are switching a little bit here to talk about adding polynomials. So we're going to do a few examples here. The first thing we need to talk about, though, before we do that is a vocab word. So you might want to get your highlighter out. And that is, I'm spelling this wrong, similar, or most people say like terms. So similar or like terms, those are terms that have the same variables raised to the same powers. Terms that have the same variables raised to the same powers. So that basically means that the letter part of them, the variable part, they look exactly the same. Like x squared y, they would both have to have an x squared y. Or maybe if one was like 3x to the 3y squared, the other one could be like 4x to the 3y squared. They have to have the same variable part. So we're going to do some examples where we do something called combining like terms, because if terms are like, we can combine them. So the instructions here are to combine like terms. And this is something we've been doing a lot. So we're actually going to do 3 examples here. The first one is 3x squared minus 4y plus 2x squared. So we're looking for things that can group up because they are like terms. So the two things that I see, the two terms here that have the same variable part are the 3x squared and the 2x squared. So if we add, because there's a plus in front of the 2x squared, don't let this minus after the 3x squared confuse you. That minus goes with the 4y. So a sign always goes with the term right behind it. So we're going to add 3x squared plus 2x squareds, and that means we have 5x squareds. So when you add them up, the variable part stays the same. You just add the coefficients, the 3 and the 2. And then, oh, that poor minus 4y or negative 4y, he doesn't have any friends to combine with. So we just have to leave him minus 4y on the end there, and that's our answer. We combined the like terms. There were only 2 terms we could combine. The next example we're going to do is 4t cubed minus 6t minus 8t squared plus t cubed plus 9t squared. Woo! Now don't get scared when you see a really long one. They're really not too bad. We could make it like a whole page long and it still wouldn't be that bad. It would be kind of hard to look for the like terms, I guess. So we're looking for like terms that we can combine. Now I know they all have t's, but they have to be raised to the same power to be considered like terms. So you want to start with the highest power because when we start writing things in standard form, you want to write things from the biggest power to the smallest. So the highest term to the lowest term, the highest degree to the lowest degree. So the first thing I see is that I've got 4t cubed plus another t cubed. Remember, you can think of that as a 1t cubed. So when we combine those, that's going to be 5t cubed. Sometimes when I'm doing this on paper, I cross things out as I go. I don't need to right now because I've got these different colors, but you might want to be crossing them out. It's up to you. It just kind of helps me keep track of what I've worked with already. So we did the t cubed. Let's look for things that are to the power of 2, t to the power of 2. So I've got this negative 8t squared plus a 9t squared. So I can combine those. Negative 8 plus 9 is a positive 1. So you can write plus 1t squared, or you can just write plus t squared. You don't have to write that 1. You won't get taken off for writing it, though. And then last, we've got this poor minus 6t who doesn't have anyone to combine with, so he's just hanging out in the end, just chilling there. And that is where we leave it. 5t cubed plus t squared minus 6t. All right, let's do another example. We combine like terms. We just want to get a lot of practice with this so that we're good at it. So we're going to combine like terms in this guy. 3x squared y plus 5xy squared minus 3x squared y minus xy squared. So if you look at this one, every single term has both an x and a y, but they all have different powers. So remember that if things are considered like terms, they have to have the exact same variable part. So what I'm seeing here is that I've got this guy that has an xy squared on it, and so does this guy, x squared y. One is a positive 3, one is a negative 3. So we can combine those guys. 3x squared y minus 3x squared y is just 0 x squared y, or just 0. So we're going to kind of just forget about that one. Now we also have these two other terms, and it is 5xy squared minus an xy squared. So those are like terms. They both have an x and they both have a y squared. So 5xy squared minus 1xy squared, that is 4xy squared. And that's going to end up being our answer. It's a monomial. It's just one term because that other term was 0, and we don't really need to write plus 0. The adding 0 won't really change anything. That's the identity property. All right, I've got 2 more examples and we are done. You guys, this might be like a record short video. So next we're going to add 2 polynomials together. Adding is really nice when we add polynomials, so you might see it written like this in parentheses. So we're going to add negative 3x cubed plus 2x minus 4 we're going to add that to another polynomial, 4x cubed plus 3x squared plus 2. Now, when you're adding polynomials like this and you see them in parentheses, if you see a plus and then parentheses, like we see right here, you can just forget about the parentheses. You don't have to do any distributing. I mean, you could distribute a 1 right there to everything, but you don't need to because multiplying by 1 is not going to change anything. So if you see plus parentheses, if you want, you can just write the whole thing with no parentheses. Now, you don't have to write it over, but it might just make it look nicer to you so that you can combine all these like terms up. All right, let's look for our like terms here. Remember, we're going to start with the highest degree on x. So I've got a negative 3x cubed plus 4x cubed. So negative 3 plus 4, that's going to give me 1x cubed, or just x cubed. So let's work our way down. We did x's to the power of 3. Now let's go to 2. I think there's only one thing with the power of 2. It's just this plus 3x squared. So that's fine. We don't have to combine with anything. We can just write them down here if there's nothing to combine with, and that's okay. Now we'll go down to x's with a power of 1, or just x. So again, I only see one guy right there, the 2x plus 2x. So again, we just list that on our polynomial, our result. And then last we can do our constants. So I see a negative 4 plus 2. So that's a negative 2, so we can write minus 2. And that's going to be our solution there. And it's nice written in standard form from highest degree to lowest degree. All right, one more example, that's it. So we're going to subtract now. So we're going to subtract two polynomials here. We're going to subtract negative 3x squared plus 4xy. And from that, we're going to subtract 2x squared minus 5xy plus 7y squared. And you can see we wrote those in parentheses, and we put a minus in between because we're subtracting. Now we need to make sure we subtract that entire second polynomial. We need to subtract this entire thing over here, not just the 2x squared, not just the first term. So I can't just take the parentheses away now. And we've talked about this before. What we have to do is we need to remember that there's kind of like a negative 1 right there, and we need to distribute that negative 1 to all of those terms. Now remember, multiplying by negative 1 is just going to change the sign of everything. So let's go ahead, and I'm just going to write this first polynomial down exactly as it is. So I just copied that down. And now I'll use red to write in our second one after we distribute that negative 1. So now instead of a positive 2x squared, it's going to be a negative, or minus 2x squared. Instead of minus 5xy, it's going to be plus 5xy. And instead of plus 7y squared, it's going to be minus 7y squared. So that's really the only part of subtracting polynomials that's different than adding, because now we can just go ahead and find all of our like terms and combine them. So we want to start with the first letter in the alphabet that we see. So x comes before y, so we're going to start with the x's, and we're going to list those in order from highest degree to lowest degree. So I think the highest degree of x we have is an x squared, and these two are like terms, right? Negative 3x squared minus 2x squared, and those combine to be negative 5x squared. I just added up the negative 3 and negative 2, and we leave the x squared part the same. We don't change the variable part. So we did the x to the power of 2. Now let's find anything that has an x to the power of 1 in it, or just an x. So it looks like there's two terms that have just an x, this guy and this guy, and they happen to be like terms because they both have an xy in them. So we can combine those two terms. We've got 4xy plus 5xy, and that becomes 9xy. Let's see. I've got just one term left, the negative 7y squared, and so we can just write him on the end. He can't combine with anyone, but that's okay. He still needs to come along for the ride. All right, and so that's our solution, and that is it for these notes. Okay, they weren't that short, but under 15 minutes. That's pretty good. So come to class tomorrow ready with questions and ready to do some practice problems.